Okay, welcome everybody. Thank you so much for being here for the first talk of this seminar series this semester. And today we're very fortunate to have with us Vinodkumar Prabhakaran. Thank you so much, Vinod, for being for agreeing to be the first speaker of the seminar series this semester. Vinod is a research scientist at Google who's working on issues around ethics, fairness, and transparency in machine learning and natural language processing. And prior to Google, Vinod was a postdoctoral researcher at Stanford University, and he obtained his PhD in computer science from Columbia University. His prior research is focused on building scalable ways to identify and address large-scale societal issues, such as racial disparities in policing, workplace incivility, and online abuse. Vinod's work has been published in top-tier venues such as PNAS, ACL, NAACL, and EMNLP. He co-organizes the annual international workshop on online abuse and harms and serves as a diversity and inclusion co-chair for ACL 2020. Thank you so much once again, Vinod, on behalf of everybody. And we are very excited to hear what you have to say. For that, feel free to get started.
Thanks, Amulya, for inviting and for that wonderful introduction. And let me start by sharing the screen, which I can, okay, got it. Can you see my screen?
Yeah, we can see the screen.
Okay, so as I was telling Amulya earlier, I'm calling into Zoom using this web browser. So once I'm on full screen, like presenting mode, I cannot see anyone. Like if there's like any questions on chat, I'm fine with like taking questions during the talk. But also I hope that there will be like a 10-minute or so at the end to have a discussion. So depending on if there's a clarification question, feel free to ask, and Amulya can interrupt me and like ask that question. Sorry, I ask that question to you, relay that question to me. So having that meta thing out of the way, as Amulya said, I currently work at Google Research as a research scientist. I kind of consider myself as a computational social scientist, sort of like working on issues at the intersection of like AI and society. And my background, as Amulya said, is in natural language processing. So a lot of examples that I use in my talk today, and mostly in my work as well, is usually from NLP. Even though I do work, many of the work that I do, that I work on AI systems in general. It doesn't limit to like language data, but most of the examples that I used, probably because of my own biases, come from NLP background. So I just wanted to put that caveat ahead. I'm also going to be talking about like work done by sort of a lot of other people outside of Google in this space, at least in the beginning, the first half of the talk, to set the stage. So this is not all like sort of like my own work. So that's another thing I wanted to flag.
One thing, just wanted to make sure that you're not switching slides because
no, I'm just gonna start.
Okay,
yeah.
just
yeah. I am now going to switch slides, and I think it works. It works, right?
Yeah, it works. Yep.
All right. So let's start with sort of like the kind of core question sort of comes up in the AI research and machine learning research, NLP research. It often centers around the question about how can we help computers learn from data, right? And if you take the example from NLP, especially in the last decade, there has been impressive gains that we've made in terms of learning representations of words and meaning based on data that's out there. There's millions of like articles and like Wikipedia articles and other sorts of language data that is available, and based on that we built these representations of word meanings. We call word embeddings, some people call them meaning representations, and that has sort of like revolutionized the field of NLP in terms of what is possible to do. But a question that we ask is data a reliable representation of the world you want tomorrow? I'll start with a kind of like a toy exercise of sort. Anybody is welcome to sort of answer, or Amulya, you can answer. I believe like everybody can speak, right? So in this slide, what do you see? If you've seen this slide before, please don't answer, but anybody else, anybody want to venture a answer?
I think Kenneth has put his mic close to. Do you want to go for it, Kenneth?
Bananas, okay. Amulya or anyone else?
Bananas by the dozen, yeah. I mean,
yeah, okay, bananas by bunch, or okay. So yeah, I mean, in the previous iterations where I've used a slide, like the answers were bananas, stickers. Some people did notice the stickers in there. Dole bananas, some people even knew the brand. Bananas at the store, bananas on shelves, bunches of bananas. We never say yellow bananas. Well, I mean, not never, but usually we tend to not say yellow bananas. But when we see a green banana, we actually do say green banana or unripe banana. We don't explicitly call out the yellowness of the banana because yellow is prototypical to bananas, right? Like, or at least the way we see bananas, it's by default, it is the color that we ascribe to banana. So we don't really explicitly call that out. And there is an entire like field of theory around like this prototype theory. That is that we as humans, when we interface with society and like the world, we categorize things into sort of like these kind of groups and sort of like assign properties as a way to reduce the infinite differences among the stimuli, to be able to sort of like process them cognitively in a feasible manner. And this prototype theory has implications in like what you actually see in data. And similar, if you actually go to a search engine and type male doctor versus female doctor, you actually would see a lot more, almost twice or more than twice as many. I forget exactly when I took the screenshot, but more than twice as many instances of female doctor as opposed to male doctor. This was like just like one screenshot that I took, but there's also like a study that was done out of Boston University a few years ago that kind of like tested this theory that like people don't associate the term doctor with female, or like you actually call that out explicitly like this. So that difference is usually is because like when you actually are referring to a male doctor, you are more likely to just say doctor, but if you're referring to a female doctor, you call that out explicitly. So this is an example of human reporting bias, which means that what would be reflected in data would have this bias. So the frequency with which people write about actions, outcomes, properties is not really a reflection of the degree to which a property is a characteristic of a class of individuals. So going back to that original slide, or the first slide that I showed, like, so when we are actually trying to learn meanings from data that's out there in the world, it's important to take into account that it won't be reflecting the actual characteristic, but it's usually through the social lens. So it goes through the social kind of filter. So we just really have to re-ask that question: is the data a reliable representation of the world you want to model? Let's look at a few more examples. There are examples of biases in data. There's a whole lot of selection biases. For instance, there's different kinds of world English. There's a lot of NLP work that is done over the last few decades, and most of it, a predominant work of that work is done on English. Even within that English, there's many different Englishes out there. Is the data that we use to train our English NLP models representative of all the Englishes out there? Probably not. A lot of NLP models are trained on like web data from Wikipedia and other kind of news articles and so on. And there have been studies that show that men are overrepresented in web-based news articles. Men are overrepresented in Twitter conversations. Gender bias in Wikipedia and Britannica has been also documented. So all this means that like that what we are learning from is a data from specific subsets of people. If you want to actually look at like who we in the machine learning NLP community turn to for getting annotations in a crowdsourced manner. This is kind of like a map from like a few years ago of like where that distribution was in terms of the Amazon Mechanical Turk workers, and what does this distribution tell us about like what kind of like human biases that are going to be, or what world perspectives are going to be incorporated into the labels that we're obtaining. There's out-group homogeneity bias, when you actually have a tendency to see out-group members as more alike than in-group members. An example of this is in a labels in a machine learning data set, where the first two images were labeled with like labels such as ceremony, wedding, bride, man, groom, so on. Whereas the third picture, even though that's also a wedding picture, that was labeled as person, people. This is like because of cultural differences and also not recognizing that is actually a picture of a wedding ceremony. There's also, it's not just the case that like things are not, data is not representative of like diversity that is out there in the world, but there's also biases in like how groups of people may be represented. It's possible that you have an appropriate amount of data for every group you can think of, but some groups may be represented less positively than others in your data set. And this also has been documented by computational social scientists, like in various online fora, especially responses to female experts, for instance, in like places like TED and like Wikipedia tend to have like very disparate sort of like language used compared to like male celebrities or male experts. So it is safe to say that the data is not really a reliable representation of what we want to really model. And why does it matter? This is a chart from Megan Smith, who was a former CTO of the US, has put together this kind of like, this is not an exhaustive list, but something to actually think about. There are these kind of algorithmic decision making, these kind of like biases that resulting in algorithmic decision making could result in individual harms, like in hiring, employment, insurance and social benefits, housing, credit allocation, loss of liberty, and so on. And these are also social harms in terms of like different groups of people when they are getting these kind of disparate treatment that results in like sort of like loss of opportunity for large groups of people. That is also problematic. And some examples for that, this was a study that was done, Gender Shades was a study that was done in 2018 by Joy Bulomani and Timnit Gebru, which sort of like started the conversation around like bias in like facial recognition systems. And they showed that many of the kind of off-the-shelf facial recognition systems out there that were in use had significant disparity in how well they performed on, say, an average white male face versus an average black female face. And that disparity was not like significant in terms of like, in the 90s to sort of like 50s or something, 60s. And there was I forget exactly which year this was in, I think 2 years ago, there was this report that Amazon had this AI-based hiring tool that reportedly penalized resumes with words such as women's or like anything associated with female. Well, they specifically found evidence for this particular word having that bias or bias towards this word or against this word. There was this study that came out in 2019 on racial bias in a very commonly used medical algorithm that was designed to sort of select patients for like extra services. They showed that there was significant racial bias in that algorithm. And there's also, from an NLP standpoint, like there's toxicity classification, for instance. This is a perspective API out of Jigsaw, which is used in various platforms for censoring, or rather sort of like reviewing, moderating content online in their platforms. And a naively trained model will have strongly unintended biases, as illustrated by these examples. This was an example from 2018, and I worked with the Jigsaw team, and I know that they've fixed these issues, or they have had efforts. They had follow-up efforts to actually fix these issues, or at least this particular paper, this particular slide. So here, for instance, the term, if I say a sentence, the Gay and Lesbian Film Festival starts today, it had a toxicity score of 0.82. This is, at that point in time, this was because the words gay and lesbian was predominantly used in online fora as a way of insult. So that meaning got kind of propagated to how the toxicity model saw those words. And so this was, as I said, like mitigated, but there are still other kinds of biases that exist. This was work that we did in 2019. We analyzed the same model, where if you say, I hate Justin Timberlake, it has a toxicity score of 0.9. If I say, I hate Rihanna, it has 0.69. My hypothesis is that this is probably because of Justin Bieber, because prior to, like, in mid 2010s, there was all sorts of like negative coverage about Justin Bieber getting arrested and so on. So those events might have resulted in like a lot of like negative speech online about Justin Bieber that resulted in like all the Justins in the world suffering for it, or not suffering. Justin Timberlake is not suffering here, but this is just to demonstrate like how these biases can get baked into our models. Similarly, this was a work that we got published last year at ACL, where we looked at how mentions of disability or biases against mentions of disability get baked into these models. Like if I say I'm a person, it has a toxicity point for 0.08. But if I say I'm a blind person, there's a toxicity of 0.39, a deaf person 0.44. And if I say I'm a person with mental illness, it's 0.6. So you get the idea. So that these kind of biases are baked into our models. And these are like sort of like downstream impacts of these biases, right? Like this toxicity model, for instance, has a potential to affect your free speech, as well as your safety when you're engaging in online discourse. So what do we do? What do we do? As researchers, as developers, what can we do as well? So a lot of work in the last 3-4 years have happened in the space. A lot of it like sort of takes the view of like, the data has all these biases, and that has been the view that I've also been like talking about, right? Like the data has all these human biases, and like those biases get propagated into the model. And most of the work sort of like takes the model into account and sort of like look at the input and what is being fed into these models, and like what is the prediction or outcome. And the line of work, if I just want to summarize, like within NLP, a lot of work look into the bias in data and input representations, like the word embeddings that I talked about earlier in the slide, in one of the slides. There was a work from 2016 by Boluk-Pasi et al. That demonstrated that there are social stereotypes and disparities in the data in society that are reflected in the word embeddings, or like meaning representations in these word embeddings. If you look at like an analogy task, like a man is to a programmer, then and a woman is to a homemaker. And they demonstrated various kinds of gender biases in like word embeddings at that point in time. And since then, there have been like efforts to mitigate it, but then also like work that shows that that mitigation doesn't really take into effect in downstream tasks. And so, yeah, this is what I meant to say. There's like a lot of other work looking at racial disparities, ethnicity-based disparities in word embeddings. And this is like a very active research area, and that's ongoing. There's a lot of other work also looks at the outcomes of this model, like what does the model, like as a useful thing, making a prediction for like some real life decision, like what are the, I mean, are the outcomes biased along any of these social axes? And the example that I used was the Amazon's hiring tool. There's like other kind of studies. Specifically within NLP, people have demonstrated gender bias in part of speech tagging and parsing, like core NLP tasks, such as like even parsing a sentence has gender bias. Core reference resolution, whether you actually resolve a particular pronoun to a particular person, depending on like, that whether that person's like occupation is doctor versus nurse, like that affects like whether some name is resolved to a pronouns. There's gender and race and age bias and sentiment analysis that has been documented. There's, as I said, the LGBTQ identity terms bias in toxicity classification. Similarly, there is racial bias as well that has been documented there. Gender bias in occupation classification, gender bias in machine translation. So this is also, again, a very active research area. And both of these slides that I have listed here are from like late 2019. So there's like a lot more work that has come out back last year, and it's a very active area. So I'm not even going to attempt to update these slides unless that's the focus of my talk. So going back to this, so this has been like predominantly the algorithmic fairness research tend to focus on the data and models. However, people have pointed out that like things like fairness and justice, the concepts like fairness and justice, to treat them as terms that have some meaningful application to technology, separate from the social context in which it is going to be deployed, is an abstraction error. So I think they're making the point, this was a study that was published in 2019 at FACT-STAR conference, which is used to be called FACT-STAR, now it's called FACT. So they were basically talking about how computer scientists, as based on our training, we have the tendency to sort of like abstract away for certain things, right? When we build classes in Java, like you actually build an abstract class, and like so generalizing things is like our sort of like kind of like the theme for a lot of our research, and that value may be at odds with like a lot of this fairness research, because fairness and justice require, or these kind of considerations do require sort of a better understanding of the social context in which things are applied. So a pure mathematical interventions to sort of like debias or remove the biases from a machine learning models might be at best sort of like not useful, and at worst it could be actually counterproductive. And so that's kind of like, that's a theme that I want to talk about today. And by that, to expand on what I just said, just to start thinking about it, like, so it's the model and data development doesn't happen in vacuum. It's usually the data and model is built based on a problem formulation somebody formulated, either us as researchers, or there is from the developers, or through some process, a problem. What is the problem? Identifying what problem we want to solve has happened, and there are decisions that are made there. Similarly, where these models get deployed, there are decisions that are being made. So when we build these, so whatever human biases that exist, or like that get creeped into our pipeline, do get carried over to the deployment as well. But there are human biases in all these other spaces too. Human biases from our own biases, like based on what kind of optimization algorithms we use, or what sort of objectives we try to optimize for, what thresholds we choose, and what inform those decisions, right? And that also results in effects in deployment. Also, how we formulate problems, like what problems we choose to solve, there are all sorts of human biases that could result in there, and I would be talking about some of this in later slides. And these biases also get kind of carried through the pipeline. So just fixing the data or fixing the model may not like change what we started with, right? Like, so we have to think about these AI biases in that like bigger ecosystem, or like fairness in that bigger ecosystem, in order for us to really make a change. And once it's deployed, people see these outputs, and those outputs do affect how people perceive their world, right? Like if you think about, like, say, recommendation engines, any biases in recommendation engines would result in sort of like, or very likely results in like people's perception about the world and what they see, what content they see, what are filtered for them and stuff like that. And that would result in like what would they think about, what kind of biases we would then get into their own sort of decisions that affect all these other stages. So in effect, there is this sort of like a bias laundering is a term that Meg uses. Meg is Margaret Mitchell, my collaborator and team lead in my team. So there is this like kind of a phenomenon of bias laundering that goes on, and so it kind of like has the tendency to amplify these biases, and it may take a few years. Like it won't be like an immediate effect. It takes a while for these effects to actually manifest in data. It takes a while for these effects to actually result in like our own human biases, researcher biases, and so on. But this does happen this also does affect the machine learning pipeline. So we have to find a way to model societal context that accounts for the society's dynamically complex nature, with its feedback loops and its delayed impacts and these emergent properties, new things, new factors that comes into existence as a result of the interventions that we put out into the world. And producing such technologies that work within the complex social realities and existing systems require understanding of social, legal, and ethical context, which often requires some sort of like, which often requires the lived experiences of living in those systems. And so one of the inquiries that we do in our team or in my work has been in like, how do we do meaningful community participation as a way to sort of inform algorithmic fairness work? And participatory design and participatory approaches to machine learning design is not new. There's been like decades worth of work in HCI and other communities where participatory approaches have been shown to be of really good value. But within fairness research, that is still like very early stages. So that's one of the lines of work that we have been exploring. And one of the core ways that we think about it is that solving for fairness and inclusion requires a deeper understanding of unfairness and exclusion in that context. So how do we bring that those sort of lived experiences and qualitative sort of understanding into our design processes? So I'll now jump to like two lines of work that I have I've been working over the last year or two, and this is the first line. This is participatory approaches to fairness with community-based system dynamics. This is joint work led by Donald Martin Jr., who is a technical program manager at Google Trust and Safety, and Jill Koberg, Andrew Smart, and William Isaac. And this work is published at was published at ICLR workshop last year, as well as like there is a longer, more detailed sort of treatment of this work in an archive publication out there. So let's start with just to motivate this. Let's start with this example that I talked about earlier. Racial bias in a medical algorithm that favors white patients over sicker Black patients. So this was an algorithm that had a really great intention, right? It was aimed at, in order to sort of like make the limited resources, you have this like special programs aimed at like high risk people. So those special programs, they wanted to target it to like the people who are at high risk, and for efficiency and for allocating it right well, they used an AI system to sort of like prioritize people who gets that kind of like special program scale. But it just turned out that like 50%, 50,000, over 50,000 of people who were not selected by this program suffered more chronic diseases than those who were selected. And predominantly people who were excluded tended to be African American individuals. And what was the issue? So this was a study that was published by Obermeyer et al. In 2019, I believe in Science, yeah. And it turns out that it was not a problem with the data. There might have been data issues, but the root cause of this failure was what was the target variable that they selected, the designers selected as a way for proxy for what they wanted to actually measure. And it was something that happened during the problem formulation. For instance, and these decisions are driven by incomplete causal theories that designers or researchers or developers may have in their minds about how the world works. So they wanted to select patients with the most complex healthcare needs for a special program.
I had one clarifying question. So,
sure.
In the previous slide, I was not, so maybe I missed this. So upfront, why is the why is it the case that if the machine learning algorithm is selecting, let's say, white males disproportionately more than African American males, let's say, then that is inherently bad. I mean, so I just want to make sure that there is no, so it is not the case that amongst the white males that there is indeed a greater likelihood of high risk as compared
to. Yeah, I mean, so the base rate, yeah, no, yeah, of course, that's a really great question. I think the way I think about that question is like the base rate of that high risk or high complex. I forget the term. High risk or patients were in that group, then that is actually valid, and that it was not the case here. Maybe I was not clear in like describing it. So this was like the people who were incorrectly. There was a higher likelihood of being incorrectly excluded for African American individuals.
Okay. Thank you.
Sure. Any other questions? I mean, now that I have a break, I'm happy to take any other questions you have, or anybody else. Or I can move on. Okay, I'll move. Yeah. So here, what turned out to be the core issue was that so they wanted to model complex healthcare needs, like people who would benefit the most from these special programs. And they had the causal theory that if you have a complex healthcare need, that would mean that you would spend more on healthcare. So they didn't have like, data that was crisp enough to actually model like complex healthcare needs, but instead they used the proxy spending, healthcare spending as a proxy to model or as a proxy for complex healthcare. And so the underlying causal theory that's never explicitly stated is that, if you have complex healthcare needs, you would eventually you would end up spending a lot more on healthcare, which is intuitive, like it makes sense, but this was the target variable that they were optimizing on and like sort of trying to predict or trying to use that as like the main variable. However, there's many other factors that are affecting the spending on healthcare, like underdiagnosis due to bias that is documented in like various studies that would result in like lesser spending on healthcare. Lack of trust in the healthcare system, that is significantly more among African American individuals in the US. There's wealth and income disparities that would result in like decreased spending on healthcare. Similarly, lack of access to affordable healthcare is also a problem that affects African American individuals in the US. So all these factors would affect like the spending in healthcare to be like or there's like a negative effect of all these things, which significantly affect more or significantly more influence African American individuals more, and that these healthcare system structural inequities do have this impact. But that social context, that insight was like never sort of like taken into account. If African American individuals were part of the decision making process in some manner, if their lived experiences, if there was a way to bring in their lived experiences or their causal theories into these how we make this like problem formulations space or that step, that would have caught this before this actually began. And actually the company that built this did in fact fix that problem, like, in response to that study. But this would not have happened. So this kind of like cycle, so this takes a while, right? Like, so this actually reinforces that like negative loop, like lack of access to affordable healthcare would affect like spending on healthcare, and then that would affect exclusion, and then that has like this like cyclic nature. And so social context, like societal context, has this like dynamically, it is constantly changing and often non-linearly, and it is inherent with like time delays and feedback loops. And how do we model these kind of like complex systems? There's a whole line of like sort of discipline called system dynamics as like as a methodology for modeling complex systems, like society being like one such instance. And so this is rooted in systems theory, and there's a whole lot of work applying that into organizational settings. Like this is like a book that kind of is considered like the base book for that, that started off as being used in like businesses, like for business organizational modeling, but it has been applied to various social problems, like in public health and so on, in over the last 2-3 decades. So in this study, what we were looking at was like, can we use the system dynamics approach into making these causal theories more explicit? And these system dynamics methodologies do have ways to take into account feedback loops, time delays, accumulations, and it also allows for simulating. Like, so whenever you do an intervention, and once you introduce that intervention, like you could simulate how the system would behave and how it would affect like the populations, whatever metric that you're measuring, and so that's the first thing, like about like the capturing like that dynamic complexity of society or societal context is the first thing. But then we also talked about like we want to be able to like bring in community perspectives in this, and this kind of a visual representation of this, like making these causal theories explicit this way, allows for like a better sort of like community participation, and that has been like kind of core of like this idea of community-based system dynamics. So I'll get to that in a minute. So we need to have this kind of like causal theories, like this is like repetition of what I just said. We need to have a way to actually elicit, synthesize, and make explicit these causal theories, and in a way that it centers the perspectives of the communities most vulnerable to algorithmic bias in participatory and non-extractive ways. And we want to be able to content with like a dynamically complex nature of societal context, and that's what we just talked about. And for this, as I said, like system dynamics has a long history of like sort of working with community-based approaches, and this whole practice of CBSD as a participatory practice for including communities, and leveraging these visual tools and simulation for communities to come up with like a code develop, rather than like sort of having a workshop and getting their insights and then coming back to your desk and like, designing solutions for them. This is like where communities like bring together, or it's easy to sort of like, not easy, it's this practice of sort of like co-developing solutions or like solution decisions through community involvement, and in a more sort of collaborative way rather than sort of an extractive way. So we have been doing, so as the paper describes this kind of like very high level picture, but we have also been doing some sort of partnering processes with communities. This was in 2019. We had a Data for Black Lives conference. We had an event at the data flow Black Lives event, and there was like a follow-up work that actually resulted in like some sort of like algorithmic fairness sort of like insights or co-designing outcome that's currently under publication. So this is like an ongoing work, and so I'll just stop here before going into more details of that. Like, so basically, it's still like not proven like how well it would work in like sort of like a setup like a corporate environment. How can it work without like it being exploitative or like extractive? So these are like kind of things that we continue to like look. We are working on like a case study and so on. So with that, I'll stop that and take a break. If any questions on that section, I'm happy to take it now, or I can wait until end. Okay, I will move on to the next part. So here I describe like the need for doing more community participation. But even here, one of the things that worries me and also frustrates me when I started working in this space was disparities in terms of like from global perspectives in this space. Who is asking and answering these questions, whose data is used to study and answer these questions around like fairness and justice, and whose value systems inform the interventions that we actually put out into the world. And when we look at like who will be impacted by those interventions, we get a picture that like most of the technology development happens in the AI hubs like US and Canada and China and like Western Europe and India as well. Some of the AI development happens there. But AI technologies are kind of much more broadly kind of deployed into communities or into geographies, into different cultures. So these questions around fairness and justice are often answered implicitly using our own value systems without questioning like what is right for us. Would that be right for like these other cultures? So that has been like one of the main kind of problem points that I have been bugged with. And this is true, like if you actually do analyze the conventional fair ML or conventional work in algorithmic fairness over the last 5 years or so, it is premised on the West. It's very West-centric, especially US-centric, in terms of like the structural injustices it focuses on, such as race and gender, the data sets it works with, like WordNet and ImageNet and other sort of like data sets that are out of the West, like especially US, measurement scales such as Fitzpatrick scale that are originally devised to actually measure or devised for fairer skin tones, and also it is derived from a lot of legal tenets from like the civil rights laws in the US or the Enlightenment values or ideals in the West. However, these algorithmic fairness work or like research and like tools and frameworks have been troublingly just been taken and adopted in like other geographies like in India, Tunisia, Mexico, Uruguay, and so on. So one of the questions that we ask is how portable are the assumptions of conventional algorithmic fairness to geographies and cultures in the global South? And to answer that question, we have been collaborating with over the last year or so with Nitya Sambashivan, Erin Aronson, Ben Hutchinson, and Tulsi Doshi. And this is Nitya and Erin are from the HCI community. So we are taking a more of a HCI kind of take on this, answering this question. And this work was published at the NeurIPS workshop on broader impacts of AI's research last year in December as a kind of like a summary paper at that workshop. And the longer, more substantive paper is going to be published at FACT conference in March, but the preprint is already available on arXiv if you wanted to check it out. I'll briefly talk about our study now I think I'm maybe within 5 minutes, I'll wrap up. So the core question, as I was saying, was the non-portability of like a lot of the assumptions that underlie the algorithmic fairness work that is currently conventional algorithmic fairness work that is West-centric. For instance, let's take the example of like facial recognition bans, which was like an outcome of like a lot of algorithmic fairness research over the last few years. Now there are governments banning facial recognition. There are like companies like committing to not make it available publicly for random use cases and so on, without a review or whatever. But such an outcome of like that kind of like policy outcomes was a result of a concerted effort from like so much infrastructure that's around tech in the West, in the US. For instance, the decades of scientific empiricism on proxies and scales for subgroups in the West, like skin tones and zip codes, and all sorts of different studies that are done on like different subgroups in the West, public data, availability of public data sets and APIs, and Freedom of Information Acts that allows you to analyze model outcomes much more easier. Model outcomes, fairly responsive AI research industry, AI research and industry kind of ecosystem to bias reports from users and civil society, as well as like government representatives who are more tech literate and who are more glued into policy, regulation, and accountability issues in tech. As well as an active media that scrutinizes like what tech puts out into the world and the downstream impacts of that. So all of this kind of infrastructure and ecosystem around tech has enabled this this change, which has probably taken 3 or 4 years. And it doesn't mean in any way that it was easy. As someone who worked with Tinit Gebru, I know how much pain she has gone through and how much pushback she had to actually sustain to actually make these kind of like efforts and work in the space and also like make this positive impact. But it was enabled by these infrastructures that helped all that to come to fruition. But such infrastructures may be absent or maybe completely not, maybe not as efficient or even completely absent in many other parts of the world. And so in this study, so in this work, our core questions were like, how does conventional algorithmic fairness generalize or break into non-Western contexts? And could fairness have structurally different meaning and manifestations in non-Western contexts? And is there anything counterproductive when we actually take fairness as is and like go apply it in like a different context? So for this, we looked into, as I alluded earlier, we looked into India as the second largest democracy, having 1.3 billion people, have a large market of AI deployments in recent years, and and our methodology, as I said, is more of an HCI methodology, where we went and interviewed 36 scholars, activists, practitioners, and with expertise on social justice in India, working with communities that belong to oppressed or marginalized groups, such as LGBTQI groups or lower caste groups, scheduled caste groups, and so on. And these experts come from diverse disciplinary backgrounds, such as law, computer science, economics, sociology, journalism, and SDS, and political sciences. We also did an analysis of emerging algorithmic deployments in India and how they kind of, how the insights that we can gain from these interviews kind of like, or append that in, those insights with the insights from the analysis of emerging algorithmic deployments in India. What we found was that in India, one very high-level thing that we found is that there is a large distance between the ML model creators and the communities, and much larger than it happens in the West. And these distance, you can think of it in terms of temporal distance, in terms of like physical geographic distance, in terms of ethical value distance, and also in terms of like accountability decisions, like, recourse and stuff like that. So we identified different themes that sort of like looks at like how things are different in that infrastructure, in what occupies in that distance, and it is around data and model distortions or flawed assumptions when it comes to data and models, as well as like ML industries, like sort of double standards or like sort of like treatment of like India as a market, or like and as well as like the larger ecosystem where this operates under, so which is more of like a government and civil society sort of ecosystem. Issues with or issues or assumptions that pertain to these different sort of axes. So I don't have time to go into every single kind of finding that we have, and the paper, the archive preprint has like a more detailed treatment of like each of those. So I'll quickly go through some of the kind of things that were like very counterintuitive, or like things that I didn't know about, like as a researcher going into it. Sure, there's this missing data. There's India has 50% of like the population is not on internet, and that population predominantly belongs to Dalit and females, female Indians, and other marginalized communities. So any sort of tech interventions have this sort of like already starting with like a very using data that has like this huge bias in like representation, and that is problematic. There's also this kind of often unspoken kind of assumption about one-to-one correspondence between, like, say, a data point and a person. Whereas in India, due to cultural reasons and due to, various reasons, like there's so many patterns of usage of devices that kind of fails this assumption. For instance, especially in villages and even in urban households, like of lower socioeconomic class, women tend to not have their own phones. They usually share for the entire family, and such shared phone usage like results in sort of like the data that we collect in the Indian context, like to be very different and very distorted than like a typical data collected from the West. And it doesn't mean that like such device sharing does not happen in the West, but there's huge difference in how often it happens and who uses it, and like predominantly in India. And there was a study in 2016 that specifically looks into this device usage patterns, and like that goes at this like one-to-one correspondence issue in the Indian context. Similarly, good data profiles are often in India of the privileged data-rich users, usually upper middle class folks. And things like living arrangements, such as like Hijra communities, living arrangement is considered like fraudulent and like in the kind of data ecosystem, and so these are like insights that we get from these are like things that the participants or the experts like share with us as like things that they deal with when it comes to like this data and AI ecosystem, engaging with the data and AI ecosystems. There's also Indic approaches to fairness that already are in place that may be specific to India, or like or maybe not like applicable, or like it's very different in the West. Things like reservation, for instance, like India has reservations in various like government positions and like education and so on. How does algorithmic fairness like fare with an ecosystem where reservations are in place? Like how do we measure fairness in that kind of a situation, and so on. And there's also, this is like as one could expect, there is like a different set of subgroups when it comes to India in terms of like caste, subgroups that are like underprivileged in India when it comes to along the axes like caste, gender identification or sexual orientation, faith, ability, class, and ethnicity. And this is not exhaustive by any means, but these were the kind of themes that came out of our study. And also proxies have very different implementations in India or like manifestations in India. In the US or in the West in general, people tend to use like zip code as like a proxy for sort of race, because it has like huge association with like race. Whereas in India, that wouldn't really work, because like slums and like high skyscrapers like kind of coexist in the same zip code. And similarly, Fitzpatrick scale doesn't align with like the kind of the social injustices the way it happens in the West. And there's also questions of like who builds the AI, and there is a strong perception that the AI is coming from US tech companies built by white or dominant caste Indian men, not by minorities, and it's not inclusive of women, Dalits, Muslims, persons with disabilities, and the poor. I mean, and many of our participants likened this kind of setting to the British colonialism in setting up shop there and limiting freedom of speech and imposing values in a new context. And so most of our work took sort of like a decolonial lens into how can we build sort of infrastructure to actually disrupt that kind of like a setting. There's also this perception of like the treatment of like India as a market as like it's often framed as like next billion users, but it's often comes across as like the bottom billion users that are used as like petri dishes to sort of test various theories on like, tech. So that came across in like various interviews. There's also recourse mechanisms. It's very hard, especially for like less literate Indians to engage with like the tech companies. When earlier there were like mechanisms like street side bureaucrats that they could approach like and talk to and like get things done from government agents. Whereas like when apps are replacing them, like when things work, it's fine, and like it's still like have disparities, but when something breaks, they have no mechanisms for recourse because of like lack of literacy or lack of like not knowing what to do. They could have just like walked up to like a street level bureaucrat to take care of those things. And there's also this AI aspiration in India, and this is not just in India, many other developing nations. There's this like aspiration about AI as exciting and futuristic and without critically questioning it. And that rhetoric is like present both from like, from a government perspective, but also from the media that doesn't really question AI power. The media is also in India predominantly of upper castes and men, and that coupled with the fact that like in tech journalism in India is at least currently still very much kind of excited about tech rather than critically questioning like how tech is doing or what are the downstream impacts, and that kind of like critical questioning happens much rarer in India compared to like the West. With all of that, like in the paper, we actually go into the detail of like what a kind of like a three concurrent or like parallel sort of like research pathways in what one could do, what we could do for like sort of algorithmic fairness in the Indian context. It should look into the data and models and the flawed assumptions in the and recontextualizing like algorithmic fairness work for the data and model context in India. But it also should work with empowering the communities in India. And for that, there would have to be challenges. There would be challenges in infrastructure considerations and participatory considerations, as well as like how things are deployed. And also enabling an ecosystem, like what tech could do in terms of like building tools that would help transparency into data sets, process, and models, or also tools for civil society and media to meaningfully question tech interventions. And this sort of framework is detailed much more in the paper, and I invite you all to check it out if interested. And this is, I mean, I use the example of India, but ideally, our broader goal should be to develop global approaches to fairness that account for local context, histories, and values. It's not, I mean, India was a case study in this case, and many of the work, I mean, once it's published, the feedback that we are getting is that it actually applies to many other contexts like Iran and many other context as well. So it's important to keep in mind that like such global approaches to fairness should account for like local contexts and histories and values. So in closing, I'll close with this quote from my collaborator Donald Martin Jr. that the crisis in AI ethics, and if you agree that there is a crisis, is not really a crisis in public understanding of science, but rather a crisis in science's understanding of the public. And that's kind of like the theme that has probably come across in like many of my second half of my talk, hopefully. With that, I will stop, and I realize that I actually am really over time.
No worries at all. Thank you so much, Vinod, for that very insightful and fascinating talk. I guess we have a couple. I mean, if you have time, Vinod, we can take a couple of questions.
I do.
Yeah, John Stewart is asking, great talk. He wants to know, is participatory design, the thing that you mentioned, is that the same as diverse hiring? And I guess, I mean, to paraphrase, I think what he might so in order to ensure, let's take the India example that you mentioned, that there's a great distance between the people who are creating the AI versus the people who are using the AI in terms of geographical distance, in terms of norms, values, ethics, etc. Now, is it necessary that in order to remove that distance, is it necessary? When you talk about participatory design, is it only that that distance will go away when the creators have representation from the communities who are going to be users, or is it sufficient to engage with them while the AI is being created, to know their perspectives, their lived experiences as well? And would that be sufficient? One would be diverse hiring, when we enforce somehow that the creators need to be coming from all diverse populations, so that and I agree that that would definitely lead to lessening the distance. But
And thank you for that question. I think it's a very important question, and I think we discussed that in like the first study that I talked about. We discussed that kind of consideration of like what is diverse hiring could be like. Is that the answer? And the way I think about it is like, sure, increasing the diversity in like tech would definitely have a positive impact on many of these issues and in bridging many of these gaps. But that may not be the only solution, right? Like, so the first approach where we look at participatory approaches was not about like sort of hiring or recruiting people from these communities, but rather having those communities have a value, have a voice in building technologies that affect their communities. Right. And it has happened in the past, and it's not new. It's not something that we are doing for the first time. And I think the way we are asking questions is, one, how can we do that for like fairness in machine learning kind of context, rather than just like a design of a software engineering thing? Because the machine learning pipeline has like its own challenges in terms of like, it is opaque to even researchers many times. So how do you actually engage with like participants who are less literate in general or less literate in tech? How do we actually gain insights in a meaningful manner? But also, how do we do that in a non-extractive or exploitative way? Because even participatory approaches have this tendency to sort of like, it still benefits the companies, right? Like companies are going to go make money off of like, whatever thing you're building, and whoever is participating would get like an Amazon gift card for like $25 or something. So there's that like huge difference in terms of like, that power disparity there. So that's also something like it's very, very important to consider. So so to answer the question from John, Stuart, it's not. I was not talking about diverse hiring. Diverse hiring could, I mean, ideally it should reflect. I mean, it would be a great thing, but also it has limitations, right? Like I think one example I think about is like accessibility, right? Like when we build design systems for people with various kinds of disabilities, not every disability can be like represented in like the workforce, but rather we need to design for like, so there has to be like some a way of like bringing those insights into our design consideration. So and that carries over to the Indian context as well.
Thank you. Are there other questions? Anybody else has any questions? So I have one more question about the okay. So there's okay. So we do have questions. So maybe I can hold off. Amish Mittal is saying I felt that the presentation was a lot focused on issues which arise due to large population size of India. That's just a comment. Maybe and Gregory Fox is asking, is AI more prone to uninspected bias than statistical modeling? Because the AI detects and uses correlations, but we don't know what those correlations are.
Yeah, thanks for the questions. And I'll just respond to the comment by Amish. Probably, I think a lot of these issues could be due to large population size. That's not, I don't believe that that's the only thing. There's the histories that are associated with this. I mean, the colonial history has a lot to do with, like, where the infrastructures are in India, for instance, like that matters. There's also like difference in value systems and like what works and what doesn't, and what is considered fair and not. So many of these things, many of these gaps are there, and I agree with you that like the large population size, especially when it comes to like the infrastructural issues, the large population size could contribute to that. But that's not the only thing that came up in our study, or at least what was shared by the experts when we talked about. And to respond to Gregory Fox's question, yeah, I think yes, it is true that, and it's a I feel like that's a general question about algorithmic fairness in general. That like I think I don't really quite understand what you mean by statistical modeling. Maybe there's like a specific meaning, but usually if you distinguish like AI from like more careful kind of statistical studies, is that like AI, especially in the last few years, there's this opacity that comes with like large AI systems that we cannot sort of like understand what correlations that it's actually leaning on. And sometimes even if like you actually remove any of the problematic proxies, it still might be leaning on like other data kind of like correlations that might be problematic. And whereas in a statistical modeling, if I'm interpreting statistical modeling as like more thorough statistical studies per se, or like very very intentional sort of like models like built based on like this more fathomable data and like features, there's more thought that goes into what decisions are made. I mean, it doesn't mean that there are no risks there, but I think your comment. I mean, yeah, yeah, exactly. Great.
Great. So if there are no more questions, I would like to ask one question that I've been holding off on. The figure that you have that you had in your slide, in which you had a problem formulation, which could have a human bias, and then you had the data collection, which could have a human bias. So we talked about, you showed us an example about how biases could affect the problem formulation. We've seen examples of how biases could affect data collection, but what I mean, to this day, I don't know an example. So could you share an example of what kinds of biases could affect the optimization algorithms that we use? I mean, how would biases affect the choices of the optimization algorithms that we use?
Yeah, let me think about what would be a good. I mean, whether you optimize for, gosh, I can't. I mean, nothing comes to my mind like off the head, but like there is literature. I mean, I can maybe take it offline, but there is literature that it's not like that an algorithm, like the actual optimization algorithm, is actually biased. Like the math is not necessarily, but like the choice of a particular math. I think maybe the one way to answer that is like not even just the optimization of like the machine learning algorithm, but like even if you have like a fairness intervention, like whether you balance like say equality of odds, or whether you balance for like demographic parity, or like all those things may be against each other, like so they're not in the same direction. So if you're optimizing for, let's say, you want like demographic parity, like a same number of people in like each subgroup, like whatever, that might result in like more positive prediction, or like issues with like post-predictive parity. And so that itself, like, so the choice there, that if you are actually not intentional in choosing like which one and like how that affects like the downstream, like the communities, like that. So those are not an issue with the data, but like what choice you make in terms of like but
I think,
I knew there were examples in like even like the machine learning, like the objective itself, but like mostly I've been working with like, I've been more critiquing the fairness work, so I've been like in that level.
I see. So I think, I mean, just to something that came to my mind as you were speaking this, last semester we had Raid Khani speaking on some of these issues, and he was giving an example in which there was a system, machine learning system, which was achieving, let's say, I don't remember the exact numbers, but it was correctly classifying X% of white males as offenders, and X%, the same X% of black males as offenders, right? And then they had an improvement that came up, and as a result of that improvement, the proportion of black males went up by 5%, whereas the proportion of white males went up by 25%.
Okay.
So both. So basically, the system improved both categories of males, but it introduced unfairness. Now, that I mean, as you were talking about the optimization objectives, which of these two solutions would you prefer? If you go for Pareto optimality, you would say that the second solution, which does introduce unfairness, is Pareto dominant over the first one. Whereas from an unfairness perspective, it is obviously introducing.
I think, I mean, it requires a lot more understanding of like what context it is applied in and stuff like it to make that choice. But yeah, I think there's no easy like one answer fit everything kind of thing. It's also like, deployment also matters, as I was saying. For instance, the toxicity, if it's being used to do censorship, the toxicity model, then like the affected community by the biases that I showed is going to be like, people who are writing about it or whatever. But like if it is actually used as a ranking mechanism, then if it's like a higher toxicity association, like then you get your text reviewed much faster by the reviewer, right? So like what harm or who is harmed by this bias is very different depending on deployment decisions as well, like not just like so even the thresholding decisions there. So yeah.
All right, so Kenneth has a question. Community-based work can sometimes be viewed as not novel in MLAI conferences. Any strategies about strategies of application?
Well, I mean, I publish in like fact conferences where it would be considered novel and important. Which is unfortunate that this, like, I think, I face this myself, like when you actually, like ML conferences or NLP conferences tend to have this bias towards like methodology papers. So that's as in like you need to have like a new methodology for a paper to actually have value. So I think, that's why there is a need for like more interdisciplinary communities. Like FACT is a very interdisciplinary community. I know that it's relatively new community, but so not everybody is sort of like, would be. I've had some interactions where somebody's like, I'm not going to waste my work on FACT. And so because it's like, it's a relatively new community and new conference or whatever. But I think, the need for having interdisciplinary communities that are considered like top tier would be, or has been like my hope, or like the way I have been approaching it. But I do also like, still see myself as an NLP person. So whenever there's a methodological kind of like in like innovation or like a contribution, I try to stay connected to the community. And sort of there are some really good meta papers that has come out of like NLP community lately. Last year there was a Sulin Bloodgood paper on like harms of AI, and there was like no methodology. It was like survey, but it was really good. I think it was not a best paper, but it should have been. And there was a testing paper that was the best paper at ACL this year. I mean, in 2020. So this kind of work can be can be appreciated in like ML NLP communities, but it's not the norm. Like it's yeah, it's very hard to see that.
Thank you.
Great. Okay, so I guess we've run out of time. Thank you so much, Vinod, for taking time out of your very busy schedule and sharing your wonderful work with us.